Hi folks, welcome back to my series of lessons on trig functions for A-level maths students who are in year 12. This is lesson 5 and we're going to be looking at the exact trig ratios for 30 degrees, 45 degrees and 60 degrees in this lesson. So let's start by considering an equilateral triangle. Okay, equilateral, so you should be able to figure out what each angle is. You know that already, don't you? 60 degrees. And we're going to say that the length of the sides of this triangle are 2 units long. So the next thing we do is we split that in half down one of the lines of symmetry. So when we do that, we get something like this. We've got a right angled triangle, and we can work out some of the dimensions. That's still 2 along that hypotenuse. We've split the left hand side in half, so we've got 1 there, and again we split that 60 degree angle in half, so we've got angle 60 at the top and 30 at the bottom, like that. And using Pythagoras, we can say that the length of that bottom side that we haven't got a length for at the minute is just going to be 2 squared minus 1 squared and then square root that, so it's root 3. If we start off with looking at sine, we could say that sine theta is opposite over hypotenuse. So we can say that sine 30 will be 1, the opposite, over 2, or half. And we can also say that sine 60 is root 3 over 2. Looking at cos now, adjacent over hypotenuse, we can write that cos of 30 degrees will be adjacent over hypotenuse, so that's root 3 over 2. And cos of 60 degrees will be adjacent over hypotenuse, that's 1 over 2, isn't it? Or half. Then look at tan. Tan of 30 degrees, opposite over adjacent, so that's 1 over root 3. And tan of 60 degrees is going to be root 3 over 1, which we'll just write as root 3. So we've got quite a bit of information from that diagram there. Okay, now if we look at a right angled triangle, this one's an isosceles right angled triangle, so we're going to say that each of those sides is length 1. Using Pythagoras, we can work out the length of the hypotenuse. And we can also figure out that these angles are 45 degrees. Now, if you're not sure about that, you could think about a square and dividing it down the diagonal. Those right angles in each corner would get divided in 2, so we get 45 degrees at each one. Yeah, and using Pythagoras, we get that the length of the hypotenuse is root 2. So again, we can do a similar kind of thing. We can say that sine theta is opposite over hypotenuse, so sine 45 will be 1 over root 2. Now you could, if you wanted to, rationalise the denominator. That's the same thing as root 2 over 2. Same thing. Let's look at cos. Cos of 45 degrees is, again, 1 over root 2. Or if you rationalise the denominator, root 2 over 2. And tan 45, you might know this already by thinking about the gradients. Tan of 45, opposite over adjacent, 1 over 1 is 1. So all of that can be summarised in this table. It's not given, I don't think, in the formula book, so you do need to remember this stuff. The best advice I can give you for memorising this is to look at the row for sine. Okay, so sine of 30, or if you like, sine of pi over 6, if you're dealing in radians, is a half. Sine of 45 is 1 over root 2, and sine of 60 is root 3 over 2. If you remember that, then you can work out everything else in the table. Because if you look at the cosine, it's just the same numbers, but in the opposite order. root 3 over 2, 1 over root 2 and a half. Just the same numbers but in the opposite order to sine. And to get tan, we're going to look at this in a future video, but to get tan, all we've got to do is divide sine by cosine. So if we look at dividing the value for sine over the value for cosine, what does that do? We get half divided by root 3 over 2. Half divided by root 3 over 2 equals 1 over root 3. Hopefully that makes sense. Let's do it for 45 degrees. So 1 over root 2 divided by 1 over root 2 is 1. Root 3 over 2 divided by a half is root 3. So yeah, so if you memorize the first line of the table, you should be able to work out the rest of the table just from knowing that first line. Okay, let's see if we can use this then. Find the exact value of the sine of minus 210 degrees. So here we're stringing together some concepts from previous videos. We're going to start off by drawing ourselves a quick cast diagram. All students take care. And thinking about where would minus 210 degrees be on this diagram. Okay, so we're measuring from 0 and it's minus, so we're going to go clockwise. So 90 would take us down to here, and then another minus 90 would take us there, so that's minus 180. And minus 210 then is going to be about there. That's going to be minus 210 degrees. If we go all the way around from the positive x-axis. So this angle here that it makes with the horizontal is 30 degrees. We always want to know the angle made with the horizontal x-axis. It's 30 degrees. Okay, and that tells us that the acute angle related to that is going to be this, 30 degrees. Okay, so we've got that. We know it's something to do with sine 30. We just need to look now at how the signs match up, whether it's going to be positive or negative. So in that quadrant, quadrant number 2 over here, at minus 210 degrees, sine is positive. So we can say now that sine of minus 210 degrees is the same thing as positive sine 30 degrees. And if we remember from the table, sine 30 equals a half. So there's our exact value of sine minus 210 degrees. Okay, let's do another one. Find the exact value of tan 495 degrees. So again, start the same way. Let's have our cast diagram. All students take care. Think about where 495 degrees would be. So we're going to do one full lap of the circle anti-clockwise. So we starting over here at 0 degrees, we're going to do one full lap and we get to 360. And then another 90 degrees would take us up to here. So that would be 450 degrees. And then we need another 45 degrees, don't we, to get to this point here. So that would be another 40. So that's going to be 45 degrees. And this will be 45 degrees. And that's what we're interested in. So that's 495 degrees there. Okay. So our acute angle is 45 degrees. We always measure from the horizontal. So now we just need to figure out the connection of the signs. And in this quadrant over here, it's quadrant 2 again, isn't it? Only sine is positive, so tan would be negative in quadrant 2 at 495. Tan of 495 degrees will be a negative. So we can say then that tan of 495 is the same as negative tan 45 degrees. And if we think about tan 45 is 1. So that's negative 1. Okay, so here's some questions for you to have a go at, to enjoy. work through. And I'll just sign off by saying, if you're struggling with this, you need to go back and watch all the previous videos, videos 1 to 4, because hopefully they kind of build on each other and make sense if you watch them in sequence. Anyway, stay safe. Bye for now.